Hey, welcome back to part 2 of building the Blackland adjustable razor. And we're going to get to V2 today. But first, before we do that, I want to talk about the last video and answer a couple questions that we got. The most common question regarding V1 was how disassemblable the razor is and just kind of how the handle functions with the razor. So the way the whole handle interface works is when the razor is fully assembled, the handle locks down the adjustment knob. You can't turn it at all. This is actually a great feature because this means that while you're shaving, you can't do anything to change it. It's completely locked in. You're never going to bump it and change shave settings in the middle of a shave. And to adjust it, you're going to loosen it and just simply choose whatever direction you want, tighten it back down, and you're locked in. Super dependable, reliable way of changing shave settings. And to answer another question, yes, this is a true, well, almost true 3-piece. Just assembles just like a regular DE. We had some people who were a little confused about that, but I want to reiterate, this is just a regular 3-piece razor. And the handle does not lock in. You can use whatever handle you want. Of course, we will sell it with our own handle, and that will be perfectly designed for this razor that will mate to it. As you can see here, this is just a modified Blackbird handle. This is not what we're going to be going with. This is just for prototyping purposes and testing. The second question we got was, how do you clean this thing? And can you take it apart? Now, it won't be able to be disassembled by the customer. And this version, V1, is pretty tough to clean. It's hard to get in there between the top plate and bottom plate. But when we get to V2 today, you're going to see that it's much easier to clean. The subsequent versions are really easy to access, really easy to clean, and you won't need to take it apart to clean it fully. Let's get on to the changes for V2. When we left off last week, we had two problems that we wanted to solve. First was weight, and the second issue was this wobble. So to solve the weight, we worked with Tyler from Kinetic CNC.
Welcome.
Our literal neighbor here and also our partner on this project to try to skeletonize that out as much as possible. And I want to give you guys a little bit behind the scenes of these kind of engineering discussions and show you what happens when Tyler and I work together and how that workflow goes. And so here's how that conversation went. Now let's talk the skeletonized stuff and like the reduction of weight, because one of the biggest problems for me when shaving with it is it's just heavy, and the heaviness makes it a little more aggressive than it needs to be, and also just kind of sucks to use more than it should. And so a lot of adjustable razors are really heavy, and I want this razor to be nimbler. We have more compact form with the head because all the adjustable mechanisms in the head. So I think we can really make this thing light. So talk about the skeletonized approach and the results of it.
Yeah, so obviously here I just tried to pocket out as much material as I could without sacrificing the strength of this part and also the machinability of the part. We didn't want to make it too hard to machine.
And the aesthetics.
Yeah, we wanted to make it look somewhat good, and I think that
somewhat. It looks cool.
I think it looks pretty cool so far.
We'll see.
We'll see how it looks when it's all machined up. Also reduced the width in the X direction, if you call this the X direction. So the width in the X has been shaved down a little bit. It was a little bit too excessively wide in the first version, so we kind of shrunk it down a little bit. We've pretty much brought the assembly down to a little bit, just a few hundredths of an inch wider than the blade now. So this whole assembly is going to be...
Inch.
Huh?
We're talking inches now?
Sorry, man. Sorry. Just have to deal with it.
I thought you were an engineer.
Oh, get out of here. So yeah, once we pocketed this all out and reduced the total width of this part, I actually got some pretty good results. I think it was a reduction in 30 or 40% for this particular piece.
Yeah.
Overall, out of all the pieces, there was a reduction in about, because after adding up all the pieces, we couldn't skeletonize some other pieces as much.
Right.
We
got
got
top
about
cap and the top plate are kind of the same as they were before.
Yeah, it was like a 23% reduction total.
Yeah.
Going from version 1 to version 2.
In all the head pieces.
In all the head pieces, yeah. If we could see, I should show you the top plate, which I got some pretty good skeletonizing out too.
Oh shit, I haven't seen this yet.
Yeah, so
That's
this is a little bit funky looking,
yeah.
but compared to the original, if I even still have the original.
I don't know if we're gonna roll with that, but it is interesting. This is the first I've seen this.
this one makes it very easy to machine. So yeah, this is the original one here.
Yeah.
And this is the newer one.
Well, I mean, what if
which
we put...
has some skeleton?
Oh, yeah, pockets on the bottom as well.
So this one I got down to quite a bit. I got it from like 11.7 grams all the way down to like 6.6 grams.
Oh, that's cut it almost in half.
Yeah,
like
it's
40-50%.
It's quite a lot. Yeah,
that's wild.
So, but it's the same geometry and it will still function the exact same. So.
Yeah.
But it sounds like Shane doesn't like it, so we'll have to improve the
okay. Hang on, let's talk about this. Well, let's talk about it real quick.
Sure.
It's fun. Let the people in. Let me set this camera here for a second. I mean, okay. So obviously, functional, it'll work. There's no reason why it won't work, because even though it's not enclosed anymore, it's captured on that side. You know, the opposite sides do the same work. So I get all that. I have no doubt about the function. My main issue is like this pocket. For two reasons. One, ugly reasons. I don't know if it looks good, but things look different on CAD than they look in real life. So like, it's possible that this looks pretty badass in real life. And two, polishing might be a bitch in this area.
Oh yeah.
But I am down for the weight loss, so I say we run it and see. I mean, another way, if we really want to get weird with it, we could just like through cut this, couldn't we?
Oh, through cut it all the way?
Yeah.
Maybe we'd be losing a lot of structure. I mean, yeah, you probably could.
It's that kind of thing where like,
because like if you just go like that, well then you kind of
get pretty thin out here.
Yeah, well then you get your retaining ring cut off too.
Oh, well, we don't want that. Well, that goes away.
Maybe that will allow us to actually access the retaining ring to make it disassemblable. Maybe this could be the key to disassembling it.
Now, but then it's going to be sitting there and you'll be able to see it at all times.
Not when the top cap's on.
Well, yeah, but the top cap's only on when we put it there. We want the retaining ring to be enclosed. So I don't know if we want that.
We could put holes through this area too. So we can keep the angle, but just put some holes through.
Well, how about this? I mean, for now, let's run the skeletonized version you have.
Okay.
Because we can always go back to the previous version or some combination thereof. And let's see how it does. Because I would love to get this thing, even in stainless steel, just as light as possible.
Yeah, I agree.
Let's cut the fat. Let's just see what we can do. And that might be some drastic measures. How does this impact like machinability and, more importantly, for my pocket, like machine speed?
Yeah. So I mean,
obviously more, right?
It's going to be a little bit more, but it's not going to be anything substantial. Yeah. These pockets are obviously easy. This feature here, where I've opened up and allowed access to these slots for the top cap, that was actually that actually allows me to eliminate my drilling operation to drill this hole out and then drop in my end mill to start slotting it. Instead, I can just go straight to slotting it from the outside.
Just mop through.
So that actually does help machinability right there.
Yeah, cool.
Obviously, the underside pocket will take a little bit of extra time, but if it makes it lighter,
pretty marginal.
Yeah, this part already was an extremely quick and easy part, and I think with some optimization, I don't think it's going to be too substantial.
Yeah, because it's so simple and small. Even if you add like 20%, it's not going to really change our bottom line too much.
Yeah.
Okay. Yeah, I say we run this one on the right. The more I look at it, the more I think it's cool, and I like that it's kind of out there and it's aggressive. So I think
it's pretty aggressive looking.
We should try that and see what happens, and it won't impact the look of the thing once it's assembled.
The next thing we wanted to solve was wobble. And I want to be really clear about the wobble because we had a lot of questions about it. There are actually two types of wobble. The first is the disassembled type. When the razor is in your hand, like this, just the base plate, you can move it apart. Now, by design, there will always be a little bit of wobble here. And it doesn't really matter. It's intentional, and it just comes with this type of mechanism. But it also doesn't impact shave because when the top cap is inserted, it aligns everything and makes it impossible to do this during shaving. And this movement comes from the interplay between the top plate and the knob. So there'll always be a little bit of that. The second type of wobble is much more important, and that's when the top cap is installed and when the razor is tightened down, and you can still move the bottom plate a little bit. You can see that here. It might be hard to show on camera, but there is a little bit of wobble. And we found out in V2 what the cause of that wobble was. But I want to show you the Again, I want to show you the behind the scenes of how we got there, because we took a couple interesting routes and went down some rabbit holes that wound up not being super helpful. But I want to show you exactly what that's like. And then we're going to get into where we landed for V2. So the idea, as I understand for these posts, this is a little bit of like hypothesis. We'll see how it works out. The idea for those posts is that they are, because they're cylindrical, we can get tighter tolerances on them, and then we can eliminate a little bit of that wiggle in the top plate. Is that right?
Yeah, that's right. So these are going to be in contact with two things. So with these original posts here, they're only in contact with the sides of what we called the top plate. And with these pins here, they're going to be in contact with the top plate, and they're also going to be in contact with the top cap that's going to come down. So these pins are going to be sandwiched on two sides and in a slip fit application. So with the top cap and the top plate sandwiching these pins, I'm thinking that that's really going to constrict the movement of the bottom or the top plate.
Okay, now here's our fully skeletonized V2 adjustable bottom plate. And before we get much further, I'm just going to give you a real quick sneak peek of V3, because I know you guys are going to see these holes and be like, wow, it's really ugly. But I want to show you that this is what Tyler's top plate will eventually look like, and it looks great. The reason these are here is for another issue that we're going to go into, and that is disassembly. How do we disassemble it? And we haven't, in this version, solved that yet. And so to access the retaining ring in here, we just cut these holes in. And that will definitely not make it to production, but we need a way to take these apart here to, learn and to take the springs out and use them for other things, and to we want to be as efficient as possible. So we like to take these parts and we'd like to use them across multiple prototypes if they haven't changed. So that's why those holes are there. You're gonna have to ignore that a little bit. But the big takeaway here are these giant cutouts. These reduce the weight of this razor by a lot. Like you saw in that video, we cut weight on this part by I think over 30%. Here is the first version. You can see just how much wider it is for a start. And there is just a ton more material in V1. So we hollowed all that out, and that makes this razor V2 just a real joy to shave with. It is thin, it is light, it is agile, it feels like a regular stainless steel razor. It's got some heft to it, it's got enough heft, but it doesn't feel like a burden. It doesn't feel like the big hammer we were trying to avoid. We've also reduced the top cap to match, and ultimately it's just a huge improvement. That weight loss is tremendous. And what it also does is it helps with the cleaning issue. Now we can access in here with a Q-tip easily to get in the very center. You can use a pipe cleaner to access that perfectly, and it's just really easy to clean now. So that's super helpful. All these spots are just really easy to access, and not only does it reduce weight, but it's going to make it a lot of a better ownership experience for you. You'll be able to clean in there, get all that gunk out, and that is super important. But let's talk about some of the downsides. Namely, we didn't solve the wobble at all. We tried a few things. We tried those posts you saw in the video, and what we found is that didn't do anything. It didn't help at all. And in fact, the wobble is just as bad, and also the assembled version is bad too. You might be able to hear this clicking sound. We thought that removing the O-ring that's in V1, you won't be able to see it, but there's an O-ring in here that kind of cushions the knob and prevents that wobble. We thought that maybe that was giving too much, had too much yield, and was allowing the top cap to wobble. And that it turns out to not be the case. So we removed that, and now you get this horrible metal on metal clinking. So that is definitely something we have to solve for V3. And what we found is that those posts we tried to install didn't do anything. So we actually machined a bottom plate with those vertical posts to give more stability to the top plate. And wound up adding machining complexity. It looked dumb. It made everything harder to do, and it didn't help at all. And so what we learned is that there are actually two causes of wobble. They're actually not the same thing. The first is just like we talked about. It's just that interplay between the knob and the top plate, and it wobbles a little bit. The way we're going to fix that, we're going to put the O-ring back so you don't have this. We're going to reduce that by simply making the tolerances a little tighter around that area. That'll snug it up a little bit. But like I said, we don't really care about when it's disassembled. It's not a problem. It's not a functional problem. It's just an aesthetic problem that we'd like to make a little better because it's a little more pleasing to the eye. But it's never going to be perfect, and we don't need it to be. But we're going to tighten things up a little bit and make those improvements there. The second is the assembled version. And now it turns out that that's actually has a completely different cause. Again, just a prototype handle. I want to reiterate that. And you can see that's already a little better. But what we found is that this type of wobble, this sort of type 2 assembled wobble, the cause for that is actually the joint of the thread from the knob mating with the bottom plate, not the top plate. The top plate is fixed by the top cap, so it's bound, so it can't move at all. So this is taken up by some of the, basically the allowance for the threads themselves. So when you make a thread, you might think that, oh, threads are always, perfectly mated. Well, a thread that has no room to wiggle is a thread that cannot move. It will be bound. And so you have to have a little bit of tolerance to allow the threaded parts to move. Well, if you make them a little too much, you can make it so that you can move like this even when they're assembled. Effectively, you have a nut here in the bottom plate that's moving relative to the screw that is the knob. Now, I know this is like really technical, but you guys seem to like technical stuff. So the good news about that second problem is that we can just tighten up the tolerances on the threads to reduce that. It's already actually quite small and doesn't impact performance at all, but we still want to make it even better. And so on V3, we're going to tighten up that tolerance, make it so that the threads don't have as much room to move relative to one another. So we'll get rid of this entirely. So easy fix, very good. And we have another issue to fix with this version. Most of the videos are focusing on how the mechanism works because that's the biggest challenge. But this thing also has to shave. And we found that this thing, the lowest level, literally does not shave at all. And I will show that to you. The good news is it's an easy fix. And this is the reason we focus mainly on the mechanism, because the mechanism is a hard thing to get right. The shave's actually relatively easy. But you can see here on the lowest level, we'll take it to the old shaving testing ground, and nothing. Maybe hard to tell on the camera there, but there's literally nothing happening. As you can tell, this is the primary way of testing our razors. Helpful to be a hairy Italian, but this does literally nothing at the lowest level. And you can even see here from the side, it's just, blade doesn't stick out at all. So we have like negative exposure and 0 gap on level 1, and that's just a razor that doesn't shave. So easy fix for V3. Of course, it shaves quite nicely at higher levels. And we can crank it all the way up to a monster gap. So we do have to do some refining on the gap and exposure and actual shaving characteristics of the razor. Thankfully, this is something of a no-brainer for us at Blackland. This is what we do, and getting this right is kind of the easy part of this project. It's also most important, but it's the part that we're most comfortable with. So we're mostly focused on the mechanism, and we're gonna make some tweaks to both the mechanism and to the shaving characteristics for V3. I want to thank you guys for following along. The response to video 1 was awesome. We got a ton of comments, ton of feedback. You guys are so supportive, and we really appreciate everything you have to say. So if you have any questions or concerns, just let us know. We love to hear you and have you weigh in on this. Looking forward to sharing V3 next time and sharing our progress as we continue building this awesome razor. So thank you as always. Subscribe if you haven't as always, and we will see you in the next part.